Hello, sir. Am I audible?
Yes, sir.
Okay, sir. At the outset, on behalf of the Department of Electrical Engineering, Tulsiramji Gaikwad Patel College of Engineering and Technology, I welcome our today's expert, Dr. Nitin Ghavghave, sir, for the AICT sponsored Prerna Scheme Expert Lecture Series. And today we are going to have a lecture on the microprocessor instruction set. Our honorable expert of today's session has an experience of more than 2 decades in the engineering and technology. Sir has guided many students in PG and also in the doctorate thesis. Now, without wasting much of our time, I would like to welcome Ghavghave sir and start with the today's session. Sir, over to you.
Yeah, thank you. Thank you, Professor Shah, sir. All the faculty of Tulsiramji Gaikwad College of Engineering, Nagpur, and all my dear students who are going to appear for guest get examination this year, probably next year also. Third year students will be getting chance next year. Uh, I hope the level of students who have joined this session are either final year or pre-final year, right?
Yes, sir.
Okay, thank you, sir. So, dear friends, uh, most of you have already gone through this microprocessor and interfacing theory subject last year, I mean in third year itself. Now, just to revise the things, I would like to brief about 8085 microprocessor, and of course, I will be focusing upon the instruction part of it. Hope you are already prepared this subject. I am just brushing it up, so I will not waste much of the time uh, in what revising each and everything, right? So, yeah. Intel 8085, it's a classic microprocessor. It's a silicon chip that contains CPU, that is central processing unit. In the world of personal computers, the term microprocessor and CPU are used interchangeably. At the heart of personal computers, most workstation sits a microprocessor. So I will be directly coming to the block diagram of a generalized computer system. Microprocessors also control the logic and almost all the digital devices from clock radios to fuel injection system for automobiles. So these are some important features. Well, block diagram of a microcomputer. Any computer system, I will use the computer system. Then I will come to microcomputer. Any computer system is consisting of these four important units, right? Input device, the processor or central processing unit, we can call it a central processing unit, CPU, and the output device. Memory is the fourth block. So these are the four important units or blocks which are used in every computer system. Now out of this,
Hello.
hello.
Sir, have you shared anything because we are not able to see on the screen.
Oh, sorry. The screen is not visible. Just a moment.
Yes,
Sorry.
yes. It's not
So,
visible, sir. That's
just
why.
a moment. Just a moment. Just a moment, sir.
Yes, sir. Yes, sir.
Yeah. Now, is it visible, sir? Uh,
Yes, sir. It's visible,
is
sir.
it visible? No.
Yes, sir.
Okay. So, as I was talking about microprocessor 8085, just introductory part, I was coming over here, the block diagram. You can see over here the block diagram of a computer system. If we use central processing unit in a computer system, we term it as a normal computer, maybe a personal computer or mainframe, right? There are various, depending upon the capability of computers, various types of computers are there. I will not go in details of it. But when you talk about a microcomputer, microprocessor is used as a central processing unit. And of course, every microcomputer will be consisting of these four blocks: input device, output device, memory, and the microprocessor. Is that clear? So microprocessor is the heart of a computer, right? And all the arithmetic and logical operations, they are performed by this central processing unit. Now hereafter we will calling it as a microprocessor because we are talking about a microcomputer. Of course, the uh, uh, the first microprocessor was invented by Intel 8 in 1970, right? But how the capability of the microprocessor went on increasing, so that we'll have a quick history of microprocessor, development of a microprocessor. The next slide. Yeah. So Intel's 4004 is considered to be the first microprocessor. The 4004 was later followed in 1972 by 8008, the world's first 8-bit microprocessor. 4004 was the 4-bit microprocessor. It was also invented by Intel Corporation in the United States. The first 8-bit microprocessor was invented in 1972. Further in 1974, 8080 was developed, and the most popular microprocessor 8085, which was the 8-bit microprocessor, it was also immediately in the same year 1974 it was developed by Intel Corporation. So this is how this 8085 looks like. 20 keys on this left side, 20 keys on right hand side. Okay, so what exactly is there inside this 8085, that we will see. There are basically it was already mentioned that this 8085, it is VLSI IC, integrated circuit, very large scale integrated circuit, where there are lakhs of digital circuit inside it. There are so many gates, logic gates, adder, subtractor, then counters, flip-flops, registers, and so on. There are so many digital circuits. You might have studied all of them well earlier, probably in second year itself, right? So all these circuits are embedded in a single chip. Okay, so this is VLSI IC. This is what the nomenclature of various pins. So 20 pins on left hand side you can see over here. 20 pins on right hand side. Okay, and this is what the functional block diagram. Okay, various blocks which are there inside the microprocessor are shown over here. Okay, so out of them, you can focus over here. Can you see the pointer? Here, this is the register array. Okay, B, C, D, E, H, L, stack pointer, program counter. This is what the register array you can call it as. Further, this is the accumulator. It is a special type of register which is always involved in arithmetic and logical operations. Then temporary register, flags. What are the various flags? I will let you know later on. Then this is the arithmetic and logic unit. Okay, where arithmetic and logical operations are performed. Then here is the interrupt control unit, where there are various interrupt pins are connected. Of course, there are internal circuitry of this interrupt control. Okay, so this is what interrupt control unit. Then signal I/O control, input output control. Further, this is timing and control. All of these operations, for example, fetching of an instruction, then execution, whether it is some arithmetic operation or logical operation, whatever it is, all these operations are controlled by this timing and control unit. And this is address buffer, data address buffer. Okay, many times the address is required to be buffered, to be retained for a file. Okay, or as and when it is required, it should be retrieved. So for that purpose, address buffer is used. Similarly, the data address buffer. In fact, one important thing you can note over here, that which is the most important, I would say, because the categorization of various microprocessors, they are decided by this particular criteria. Number one is the width of data bus. How much of data can be transmitted at a time? Okay, whether it is 4-bit data, whether it is 8-bit data or 16 bits data. So depending upon that, the microprocessors could be classified. So the microprocessor which we are discussing today is 8085. So it has 8 bits of data that can be transmitted at a time. In other words, the data bus. Bus is what? Can you tell me what is meant by a bus? Bus is nothing but a group of conductors. Okay. Here I have shown this piece of a microprocessor 8085. 1 to 20 on left hand side and 21 to 40 on right hand side. So here you can observe this pin number 12 to pin number 19. Okay, pin number 12 to pin number 19. These are the data pins. D0 you can see over here. Of course, it is AD0, but for the time being, let us represent it as D0, D1 up to D7. All these are the data pins. For the data on these pins, it can be transmitted to or from the microprocessor. Okay, so always remember the data bus. All these pins are grouped together to form a bus. Data bus. Okay, so data bus is 8 bits wide for 8085, whereas the address bus is 16 bits wide. Okay, so you can see over here again. Now just for a time being that it is A0 instead of AD0, it is A0, A1, A2, A3, A4, and so on up to A7. All these 8 pins, 12 to 19, they can be used for A0 to A7. They are used to hold the address from bits of A0 to A7, whereas 21 to 28. Right hand side you can see now 21 to 28. These are the pins which are used to hold the address from A8 to A15. So this is how. What is the total address bus? 16. Okay, A0 to A15, A0 to A7 and A8 to A15. In this way, uh, total 16 bits of address can be held by the address bus of microprocessor. Is that clear? Of course, what is the purpose of address and data bus? I will let you know again. The rest of the pins are used for controlling and other operations. Okay. So I will not go in further details because the time allotted to me is 1.5 hours, and within this I have to cover most of the things. Well, so all these 40 pins, they can be grouped into 6 groups. Address bus. Just a moment. Hello. हां 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 सर सर ओळखलं जस्ट अ मोमेंट सर मी माझं एक ऑनलाईन मीटिंग सुरू आहे हो या सर एनी टाइम येस सर 4 वाजता आहे मी काही प्रॉब्लेम नाही हो हो बिलकुल अगदी येस सर येस 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 हां श्युअरली श्युअर सर नो प्रॉब्लेम सर या सर ओके सर थँक्यू बाय बाय ओके हॅलो sorry for disturbance. There was an important phone for me. Hello. Can you hear me?
Yes, sir. Yes, sir.
Okay. Sorry, sir. Sorry
No,
because
sir. No,
there might be some interruptions from my side.
no problem, sir.
Okay.
No problem at all.
Well, so this is what I was talking about. So all 40 pins are grouped into these 6 groups: address bus, data bus, control and status signal, power supply and frequency, externally initiated signals, and serial I/O ports. Okay, so uh, out of which we have seen address bus and data bus. Rest of the pins are categorized into these 4 other groups: control, power supply, external initiated signal, serial I/O ports. Well, now again I just go to the block diagram of a microcomputer. Now you can think how the processing of microprocessor takes place. See, basically microprocessor 8085 can be interfaced with memory, it can be interfaced with input device, it can be interfaced with the output device. Here you can see the arrows. Data from input device can be transmitted to microprocessor. It is unidirectional. Please note this importance. Data from microprocessor can be transmitted to output device. This is also unidirectional. Further, data from memory to microprocessor, it is transmitted in both sides, from memory to microprocessor as well as from microprocessor to memory. So, you can note one important thing, that the address bus of a microprocessor is 16 bits wide, right? So how many possible combinations could have been there when there are say 2 bits? How many combinations could be? Yes. How many possible combinations could have been there? You can write in the chat box. Hello. You can write in the chat box. For two input data, binary data, how many possible combinations can be possible? You can unmute your mic and you can answer it, or you can write in the chat box also. Well, it is 4, 2 raised to 4. Okay, I just write 0, 0, 0, 1, 1, 0, and 1, 1. 4 combinations can be possible. Okay, for 3 input data, how many possible combinations can be there? No one? For 3 input combination, how many possible combinations can be possible? Are you getting my question or not? Hello? Well, it is 8 combinations. For 4-bit, it is 16 combinations. Likewise, for 16-bit data, if 16-bit combination, total combinations could be 2 raised to 16. That comes out to be 64 kilobyte. 64K means what? 64 into 1024. Okay, 1024 into 64. This many combinations can be possible for 16 bits. Right? Now, when you say address bus of 8085 is 16 bits wide, meaning of it is that 2 raised to 16 combinations can be possible for this 16-bit address. In the sense, I'm coming to this slide again. This microprocessor can address, can send the address to memory, which is consisting of 2 raised to 16 locations. There are 64K address locations in the memory, and every location will be holding 8 bits of data. Okay. Now, if you want to get some data from a particular memory location, microprocessor will have to send the address to memory, and accordingly the data can be fetched into the microprocessor. Is it clear? Okay. Now, am I audible, sir? Just to check.
Yes, sir. Yes, sir.
Okay. So, see, Shah sir, are the students available there? I mean, are they present actively or?
Yes, sir. Yes.
Yeah,
No,
because
they
I'm
are present, sir.
asking questions. The students are not responding. So let me know whether the session is coming to them or not.
Yes,
Okay,
sir. Please,
whether the things are grasping by the students or not. Well, I don't know, but
yes.
finally I will take your feedback.
So, students, questions, whatever sir
It
is
will be,
asking,
yeah, yeah.
then only
It
we
will
will
be, yes, yes. It should be
or
interactive.
not.
The session should be interactive. This
Yes,
is what I suppose.
yes, sir.
Well, okay. So microprocessor can send a 16-bit address to the memory location, and the required location can be accessed. just like a colony, in a colony of say 100 houses, if the postman or a courier boy wants to drop something to a particular house, that courier boy must know the address of that particular house where the letter or whatever is to be dropped. Is that clear? So microprocessor also wants to send something to the memory. The address must be known before dropping something. So microprocessor will send, suppose a data is to be sent to a location, say F0 F0. There will be certain instruction which will be written inside the or written using the keyboard. Of course, it will be processed, code will be executed, and the data will be sent to the particular memory location. Okay. Similarly, if something has to be taken from memory to microprocessor, that address must be sent to the memory, and the data can be taken from memory to microprocessor. So this is bidirectional process. Always remember. So memory is one part which is always involved while writing the program. Okay, and of course, I am coming to the programming part of 8085 microprocessor. And before I proceed for programming, you must understand this particular sequence of operation. The sequence of operation. Okay, I will just go to the block diagram again. Yeah, this is the functional block diagram. So sequence of operation, you please look at the arrow pointer. Can you see this pointer? Hello? Yeah, mouse pointer. Can you see?
Yes, sir. Yes.
Okay. So this is what the microprocessor, right? So while sending some command, giving some command to the memory, of course, the instruction will be written in the form of hexadecimal code. There is a hexadecimal number which has a specific meaning. Okay, and that code or that hexadecimal number will perform a particular task. Suppose you want to move something, say this is register B. All right. Now this register B is what? It's an 8-bit register. Okay. In the sense, 8 bits of data can be stored in this register. Similarly, this is another register. B, C, D, E, H, L. Okay. All these are the various registers. You want to send the data from register B to accumulator, say. Okay. Data from register B to accumulator. Suppose you want to send this particular, you want to perform this particular operation. You will have to write the instruction related to this operation. And what is that instruction? It is move B, A. Once this instruction is executed, the data from register B will be moved to accumulator. Okay, now how it happens? This instruction move B to A, B, A will be stored in memory at a particular address. Right? Everything, every instruction or every program is always stored in memory. You have to write that program. Of course, storing is not directly, it is available. You will have to write that program in assembly language. Whatever the instructions which are used, all they belong to assembly language. Okay, which is the most familiar language, and the microprocessor all the time while programming this microprocessor, all the time you have to write the instruction in the form of assembly language. Now move B comma A is one of the instructions. Okay, that is, of course, it's an assembly language instruction. Now for this instruction, as I told you, the data will be moved from B to accumulator, but this instruction will be written in the, we'll have to write this instruction in the memory. Okay, suppose at some address 1000 hexadecimal. Suppose I have stored this instruction move B comma A. Of course, it is not stored in like this. It has some opcode or machine code. Okay, which is of course in the form of hexadecimal. Okay, hexadecimal number. Move B comma A. It has an opcode of 47. 47. Remember. Please remember. Okay. So 47 is the hexadecimal number. Of course, 4 has, further it is converted into binary 0 1 0 0 and 7 is 0 1 1 1. Okay. This is how 47 is written, and it is stored in memory, and this memory, whatever is stored at 1000, it will be memory content at 1000 will be taken into the microprocessor for processing part. Okay, simply by writing move B comma A, you cannot perform this instruction. First of all, you have to store this instruction in the memory. You will have to fetch it. You will have to get this instruction in or opcode in the microprocessor. Fetching of the opcode in microprocessor. So this will be taken into, it will be placed on this internal data bus after execution. Then instruction register, it's an 8-bit register, it will go to instruction register, further it will go to instruction decoder and machine cycle encoding. Okay, here there is a timing and control signal. So accordingly the instruction will be executed, and immediately this data, whatever is stored in B, it will be shifted to accumulator. Okay, so there is a sequence of operation for executing every of the instructions. Okay, and by doing this, you have to understand what are the various units or what are the various blocks which are involved. So always remember, program counter is another 16-bit register. It holds the address of the memory which is to be executed. Okay, it is automatically incremented one by one. Okay, once a particular instruction is executed, it is automatically incremented. Okay, next instruction will be taken, further next instruction. In this way, all the instructions are taken one by one and they are executed one by one. All right. So this is what the basic of microprocessor 8085. Just block diagram and these things I have shown. I have explained, tried to explain. Now I will come to instruction part. Can you see this screen? No. Okay. Now 8085 microprocessor, as I explained, it is a programmable IC. In the sense, this IC will be operated, all the circuitry inside this IC will be operated or various operations will be performed with the help of various instructions. So how many instructions are there? In all, there are 256 instructions. Why so? Why? What could be the reason for this? Why not 300 or 200? I think it is. Anyone can tell? Anyone can answer? Why 256 only? Okay, I will tell. Data bus of 8085 is 8 bits wide. Is that clear? So how many possible combinations of 8 bits? How many combinations can be possible using the 8 bits of data? Yeah, how many? Can you write in the chat box? Whenever there is 8 bits of data, how many combinations can be possible? 256, that is 2 raised to 8. Okay. Now 2 raised to 8 combinations, naturally there will be total number of instructions will be 256. 256 types of various instructions can be designed for 8085 microprocessor. Not more than that. This is the reason, because its data size is 8 bits wide. Well, so this is one important thing to be noted. Then mnemonics are used to represent the functions to be performed. Mnemonics. Every instruction will be a combination of a mnemonic and the operand. Okay, mnemonic and operand. Every instruction. What are the various mnemonics? These are the mnemonics. Move, ADC or JMP. All these are the various mnemonics. Okay. Now, for example, if you want to write an instruction, it will be move C, A. This is the instruction. So out of this, move is the mnemonic and this is the operand part. Okay. Meaning of this instruction is move the content of accumulator A. A stands for accumulator. And C stands for the register. So move the contents of accumulator to the register C. This will be happened. This particular operation will be performed by the instruction move C, A. All right. So this is an important thing to be noted. Mnemonic and the operand. Classification of the of these instructions. In fact, there are two ways of classifying the instructions. One way, the classification based on the length. Another is the classification based on the function. Is that clear? There are two ways of classifying the instructions. Okay, I should have written this thing down here. Okay, all right. Yeah. Classification based on the length and classification based on the function. Now, depending upon the size of or the length of an instruction, there will be three types of instructions: single byte, 2 bytes, and 3 bytes. And of course, the examples are given over here. Single byte instruction, for example, move A comma B. 2 byte, move A comma data. And 3 byte instruction is move LDA address. Okay, this data or address can be anything. A data, it stands for 8 bits data. This address stands for 16 bits data. And this is the classified based on function. Data transfer group, an arithmetic group, logical group, branch group, and machine IO group. These are the various classes of or types of instructions which are, all 256 instruction can be grouped into these 5 groups. Is that clear? So every instruction, always remember, will have 2 important features. Number 1, the size of that instruction, okay, and the function which is being performed. For example, if you consider this instruction, LXI H5000, okay, this instruction, suppose I'm LXI H5000. Now, first of all, how this instruction can be defined? It is basically categorized. In fact, 2 important features can be mentioned for this instruction. Number 1 is that this is the instruction which is having 3 bytes in size. Okay, this is the instruction which is of 3 bytes instruction. Type of this instruction is a 3-byte instruction. In the other sense, in order to store this instruction, total number of bytes which will be required is 3. Okay, this is number 1. Number 2, which is the group that this instruction belongs to. Out of these 5 groups, this instruction belongs to data transfer group, because there is transfer of data. Okay, so in this way, every instruction will have 2 important features. Number 1, you can say the size, how much is the size of that instruction. Another is what is the function of that instruction, what is the function being performed by the instruction. Now, coming to all these instructions one by one. First of all, let us discuss single byte instruction. The best example I have given over here, move related instruction. So move C comma A. This instruction is a single byte instruction. In order to store this instruction, only 1 byte is sufficient. Okay. While writing this instruction, only 1 byte is sufficient. You can write this instruction. Of course, you have to write this instruction in memory. All right. So only 1 byte, and that byte is nothing but the opcode, operation code or machine code will be required. As I said, that every of these instructions will be categorized by a particular code, hexadecimal code. For example, 4F is the hexadecimal code or machine code for this particular instruction, move C comma A. Right? Now, this hexadecimal code will perform a particular operation only. And this operation is moving the data from A register to C. Okay. This will not perform the operation of moving the data from B to say D or E to A, anything, not possible. Okay, this particular code 4F is the unique code. Always remember, it is the unique code which will perform this particular operation only. Okay, and what is that operation? Again, I repeat, move the data from register A to register C. All right. So as far as length is concerned, this will require only opcode, and which is here it is 4. Now this is what the pattern of writing this instruction. How the data bus will hold this instruction. Data bus, as I said, when this instruction is to be put on data bus, all the data pins will be holding this particular data. This is D0. Okay, D1. Just imagine that pin diagram of 8085. There were data pins, 8 data pins, D0 to D7. So D0 will hold 1, D1 1, and so on. D7 will be 0. Okay. What is this? 0100 stands for 4. Okay. And 1111 will stand for F. Okay. 1111 will represent F, hexadecimal number F, no, digit F. Okay. Whereas 4-bit equivalent of 4 is 0100. Alright. So in this way, this instruction will be consisting of only opcode. Coming to 2-byte instructions. As the name indicates, this particular instruction will require 2 bytes to get stored. In the memory, there will be 2 bytes which will be required. Example is given MVI A, 80. Now, how this instruction? You can see over here this pattern. This is the pattern of this instruction. The first byte will be holding opcode, and the second byte will be holding operand. Okay. Whatever is the operand in the instruction, that will be held by the second byte. Opcode, of course, it is required for every instruction. Whether it is single byte, 2 byte, or 3 byte, it is always there. But operand, maybe it is optional. Maybe no operand, maybe 8 bits of operand, or maybe it is 16 bits of operand. Right? What is 16-bit operand? I will let you know. Now, take this example, MVI A80. Now, first of all, you can understand this instruction. What exactly happens over here? 80. This is certain data. It is directly moved or immediately moved to accumulator. This is external data, external number. Right? This is directly taken into the accumulator. Now, MVI will have a specific code, that is opcode. As I said, that every instruction will have unique code, and from the instruction set of Microprocessor 8085, MVI will have a code of 3E. Okay. So the instruction will be stored like this: 3E, 3. You can have here like this: 0011 or 3, right? And E is 1110, which is the opcode. Okay, 0011 is complete opcode. Will be 3E. In this way, the opcode will be stored, but simply by storing opcode is not sufficient, because this instruction is consisting of operand also. Operand in the form of 8 bits of data. Because operand is always there, but this is in the form of 8 bits of data. Okay. So how this 80 is to be stored? So 80 will be stored in the second byte. This is the first byte. Okay, this is the first byte, and this is the second byte. Okay. So 80 will be stored in the second byte. All right. 1000 for 8 and 0000 for 0. Okay. In this way, this particular data, hexadecimal data, of course it is 8 bits data, it will be stored in second byte. In this way, this instruction will be completed. Okay. MVI A80 will have this particular pattern: opcode in the first byte, operand in the second byte. Okay, is that clear? Then coming to 3 bytes instruction, as the name indicates, 3 bytes. This particular instruction will be consisting of 3 bytes. It will require 3 bytes to get stored. The first byte, as usual, it will be opcode. Here, what is the opcode? See, this is an example. Huh? Remember, just a minute. LTA FC00 is the instruction. Now, this LTA stands for the mnemonic. It represents certain operation. What is the meaning of this LDA? Load accumulator. Why what? You have to get something in accumulator. But what? The data which is stored at FC00. This is a particular memory address. Whatever is stored at FC00, it will be taken into the accumulator after execution of this instruction. Once this instruction is executed, whatever the data at FC00 will be taken into the accumulator. Is that clear? So in this way, this uh, operation is performed. But here, try to understand the meaning of this instruction as far as length is concerned. So LDA is the opcode. Sorry, mnemonic. For this mnemonic, for this particular instruction, 3E is the opcode, which is written over here in the first byte. So first byte will be consisting of the operation code or machine code. Again, as I said, it is the unique code. 3E will perform the execution of a particular type. Particular execution will only be performed by 3E. What is that operation? Again, I repeat, which operation is being performed by this 3E? Yes, the data at FC00 will be loaded into accumulator. Is that clear? But simply by writing 3E is not sufficient, because this FC00 is a variable. You can write any address. You can write any address from 0000 to any FFFF. If I write 00000, whatever the data at 0000 address will be taken into accumulator. If I write 1010, the data at particular memory address will be taken into accumulator. If I write FF is the last address. Okay, basically memory is consisting of these addresses 0000 to FFFF. Okay, so whatever the using this instruction, what will happen? Whatever the data that is stored at FFFF will be taken into accumulator. Right. Our instruction was FC00. Well, now if you want to store this particular address, only 8 bits will not be sufficient because this is 8 stands for 4 bits, C for 4 bits, again 0, 0 in this way. So total 16, say, look, sorry, 16 positions will be required. 16 places will be required. Bit places will be required because it is 16 bits. So this is FC00. This is 16-bit address. Of course, it is divided into two parts. One is the low order address. This is called as low order. The last or rightmost two bits, two digits of the address will be called as low order address. So 00 will be low order, and the higher significant digits, that is FC, will be the higher order or address. Okay. So in this way, this 00 and FC will be stored because this is the maximum size, 8 bits. Every memory location can store 8 bits of data, right? So first location will store opcode, second location will store low order address, that is 00, and third location will store FC. Okay, this is F1111 and 1100 is C. So in this way, opcode, low order address and high order address, they are stored. Probably I just go over here because the time is coming to end. I just summarize it. This is what the memory block you can see on the left hand side. Can you see on the left hand side? Hello? Hello? Can you hear me, sir?
Yes, sir. Yes, sir.
Okay. So
Sir,
on
it's
the
visible.
left hand side, it is the memory block. You can note the first address is 0000 and the last address is FFFF. Although you are seeing only 4 digits, but it is 16-bit address. All these are the hexadecimal digits. Please remember. This single 0 means 4 zeros. 00 in terms of binary. Right. This 0 means again 4. 4 zeros, 4 zeros, and 4 zeros. So there are 16 zeros in terms of binary. Whereas the last address is F, 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 F. F stands for how many? What is the binary equivalent of F? It is 1111, right? 1111, 1111, and 1111. So in this way, 16 bit. This is basically 16 bit. 16-bit address, binary address. If you call it as FFFF is the hexadecimal address. So locations are total. How many locations are there? There are 2 raised to 16 or 64k locations. Number 1, 2, 3, 4, and so on up to 64k. Right? And every location will be storing 8 bits of data. Okay. Whatever you write at this location, that will be stored in the memory. You have to write it first. Now, if you want to get something in, this is what the register array. Now, just look at the right hand side. P, C, B, E, H, L, SPH, that is stack pointer higher, stack pointer lower, then PCH and PCL. Program counter higher address and program counter lower address, or byte also you can say, higher byte and lower byte. So if you want to perform a particular operation, for example, LDA FC00, let us take the same example, LDA FC00. Well, now what will happen here somewhere? FC00 address is there. Okay. And at this FC00, suppose A1 is stored. This is the data which is stored at FC00. Now what will happen with this LDA FC00? First of all, you will have to write, you will have to store this instruction, right? Somewhere, anywhere you can write, you can store. Write it at 000. So this. How do I do this? At this location, suppose I write 1, 2, or 2, 3, 4. Okay, at 2, 3, 4 location. We are using these three locations: 0002, 003, 0004. LDA is a 3-byte instruction, so if you want to store it, okay, you have to write the opcode first. What is the pattern of this instruction? The first byte will be consisting of opcode. What is the opcode? Opcode is 3A. Opcode for LDA is 3A. Huh? So 3A will be written at. Just look at this memory block. Huh? Focus over here. This is 3A. 3 will be written in the first byte. The lower order address and higher order address. As I said, this if you want to store this complete address, FC00 is the instruction out of which you have stored the opcode. Now you have to store this FC00, and this is 16-bit. So you have to divide it into two parts. One is the lower order address, that is 00, which will be stored in the second byte, and third byte will be FC. In this way, this instruction will be stored. And as far as execution is concerned, just a moment, please. हो done. इथे सर्व कोणी असेल ना hello hello yeah
Yes, sir.
okay. So in this way, this instruction will be stored. And as far as execution is concerned, once this instruction is executed, what will happen? Now, how this execution will take place? First of all, this, because everything is written in memory, right? This instruction or even data at FC00, okay, whatever the data at FC00, it is also in memory. Everything is in memory. And processing is done by the microprocessor. Whatever the right hand side, as I shown over here, sorry, this one, this right hand side part, that is the register array. Okay, this is inside the microprocessor. Whatever the execution that is to be performed, it is inside the microprocessor. So naturally, you will have to get each and everything in microprocessor and execute all the instructions one by one. For example, for that, program counter plays an important role. We see that is program counter will hold the address of the instruction to be executed. For example, if you want to execute this is start execution from this point, the address 0 0 and 0 1. You see, sorry, no, 0 2. So this address will be held by the program counter. Okay. This is what the program counter, right? 0 0 and 0 2. So this address will be held by the program counter. Once this 3 is brought into the microprocessor, automatically this is incremented by 1. So it will become now 0 0 0 3. So 0 0 will be taken into the microprocessor. Further, it will be incremented to F. Sorry. So 0 2 initially, then 0 3 and 0 4. In this way, this address will be incremented automatically in the program counter. Okay, just to get the things into the microprocessor. In this way, all these three content 3A, 0, 0, FC, everything is taken into the microprocessor. And once its execution command is given, once it is executed, what will happen? What will happen? This A1, this is the data at FC00. Accumulator will hold this A1. After execution, the accumulator, this A stands for accumulator, A stands for flag. So in this way, execution will take place. Okay. So in this way, there are various instructions I tried to explain. In fact, if you want to discuss, if you want to say understand the complete classification of the instructions, you will have to go for this further instructions. I mean further way of classifying the instructions. This is how all the instructions are categorized. 256 instructions, depending upon their functions, they can be classified as data transfer group, arithmetic group. As the name indicates, data transfer, there will be transfer of data from one place to another. I have given some examples, move or LDA something. Arithmetic group, as the name indicates, it performs the addition or arithmetic operations, addition, subtraction, increment, etc. Then logical group, this group will perform the logical operations and operations or operation or XOR operation, compare, etc. Then branch group, it is the group where the program control is transferred to a particular location. For example, while executing the program, the control can be transferred. If you want to transfer the control to another location, you can do it with the help of this jump or call instructions. Jump FC00, for example. Meaning of it is that jump the control to this location. Okay. So there are various instructions belonging to this group. You can go through them detail. And further, machine and IO control group. For example, these are the three important instructions: N02 or SIM, set, interrupt, mask, or halt. All these are the various instructions belonging to this group. Okay. So with this, I take your leave. I hope you understood at least. Satone. I hope you understand the various, at least basics of instructions and the microprocessor. Okay. If you have any doubts, please be free to ask me.
Hello.
Hello, sir.
Students, if you have any difficulty related to today's, hello,
sir.
am I audible?
Yeah, right.
Okay. Students, if you have any difficulty related to today's session, you can ask expert of today's session, Dr. Ghavghave sir. Sir, thank you so much for accepting
Thank
our invitation and giving
thank you very much, sir.
our
Sorry, I cannot give more time because of my, say, due to some other assignment. Already, I have some
no,
another
no.
meeting.
Yes, sir. Uh, so, uh, so we are really thankful to sir for accepting our invitation and delivering the very core topics of the microprocessor. I hope that all these topics would be really helpful for the students to solve the questions related to the digital part, digital electronics part in the GATE exam of 2020-21. So with this, I express my gratitude from the Department of Electrical Engineering to sir. Thank you so much, sir. Now, students, we will be circulating the attendance link. You can give the attendance. And tomorrow we are having a lecture on the power electronics uh, at uh, at 2 p.m. Expert is from NIT Durgapur. So you all should join on time so that you can take the benefit of the lecture. So now you can give the attendance and uh, sir,
Sorry,
hello.
sorry, there was a disconnection from my side. Uh,
No problem, sir.
anything,
We have concluded.
anything the students want to ask me, please.
Sir, if at all there is anything, we will get connect with you.
Okay, sir.
Right
Surely,
now, not saying anything.
surely, surely,
So
sir.
if
Thank,
I will get connected.
yeah, yeah, yeah.
Thank you,
Thank you very much, sir, for giving me a chance to interact with you. Thank you.
sir. It's our pleasure, sir.
Yes, sir. Yes. Hello.
Okay, okay, sir. Have a nice day, sir.
Thank you very much, sir. Thank you. Bye. I take your leave.
Bye.
Okay. Bye.